We are final year students from RTJ College of Engineering, pursuing BTech in Computer Science with a specialization of IoT. As a final year project, we selected Smart TDS monitoring system using machine learning algorithms. I am Lima Pranvi.
I am Nevrata Alva.
My name is Rohit.
My name is N. Kavalistri.
I am explaining the object components. This is development kit and it is Arduino Uno. We have power pin here and this is development kit to Arduino Uno power, and this is USB cable and power pins, and this is digital pins and it is analog pins. Now some specifications in Arduino Uno. At Mega 328P it have processor and memory, AVR CPU at up to 16 mHz, and we have security and peripherals. Mega 16U2 processor have 8-bit and RISC-based microcontroller, and we have memory 16 KB ISP flash, 512B EEPROM, 512B SR. In processor we have TDS sensor. In TDS sensor we have 3 pins. One is data pin and one is positive pin and one is negative pin. In positive pin, in data cable, data pin is connected to A0, positive pin is connected to 3.3 volts, and negative pin is connected to ground. And we have texting. These pins are tested in water. We have getting the values.
Hello guys, I'm Rohit. In this project I worked as a testing engineer. I mainly do the collection of the different samples of waters. Based on these samples of waters, I determine whether the water collected samples are good for drinking or not. And let me show you all the sample models. And the value 0 indicates the water pH value. 0 from 40 is good for drinking, and another cluster is also there, and the cluster value is 1. And if the cluster value is 1, the cluster value indicates water pH level of 40 to 100, and the water is very good for drinking and also use it for agriculture purpose. And the another cluster is 2, and the water is not good for drinking.
Start.
Another cluster is 3, and this water level indicates water is good for drinking. And these are the 4 different types of clusters to identify whether the water is good for drink or not. And this is the code to identify the water purity level.
Good afternoon, guys. In our project, I worked as a machine learning engineer. As a machine learning engineer, we used a Python code. In the Python code, we installed different libraries like NumPy libraries, Pandas, Matplotlib, Seaborn, and SQL libraries for using different algorithms like random forest algorithm, decision tree algorithm, logistic regression, and k-neighbors algorithm. Here, while working with the code, when we open the code, first we used to give the address of the dataset like data.csv set. That Excel sheet we should give into the code first for recognizing and for training the machine learning data. And here, when it comes to a decision tree classifier algorithm, mainly this decision tree classifier algorithm is used to decide whether that TDS value is belong to 0 cluster or 1, 2 or 3 cluster. We divided the entire TDS values into a different clusters for recognizing easily. For example, for 0 to 50 values, we divided that cluster as 0 cluster, and that cluster is good for drinking the water, and for 1 result value, that water is excellent for drinking. Like we give that inputs to another different clusters also. These decision tree algorithms plays a major role for this, and k-neighbors algorithms is majorly used to classify that clusters. Like if the TDS value is between 78.6, if the TDS value is given like that, it should predict the nearest value. We should train the data by giving a random values to it. Like that, it will take the nearest value and throw that nearest value into a cluster, and it will give you the output. For that reason, we use k-neighbors algorithm, and we use SVM algorithm and logistic regression algorithm. This logistic regression algorithm is majorly used for representing the binary values like 0, 1, either true or false, happy, sad. For that, we use this logistic regression algorithm by calculating the nearest values from the given values. And here we will use the visualizing part. In this visualizing part, we use target variable distribution, where it generates the bar graph there by predicting the test accuracy and the train accuracy. Right, for that we gave the test accuracy and train accuracy, we gave 100% for different algorithms. Like for random forest we gave 100%, for decision tree classifier we gave 80%. Like that it will generate a graph. For that we use this visualizing section, and for the test accuracies we use a classifier names like RFC, TTC, KNN, SVM and LR for classifying the different algorithms. And coming to the code, if the this code mainly gives to the output like the TDS values, we cluster the TDS values into a different result zones like 0, 1, 2, 3, and we will give the outputs in a if-else statement. By giving the if-else statements, if the result is 0, then it will use a good water. The major advantage for introducing the machine learning algorithm is easily we can predict that the water is good for drinking or not. Before introducing the machine learning algorithm, we know the only TDS range of water, so that many of the people from the urban areas, they don't know whether that water is good for drinking or not. If we introduce this, everyone can easily understand, can identify that the water is good for drinking or good for another appliances, like using it for cleaning or using it for agriculture or for industries. Thank you.
I am here to explain about the future scope and advantages of using machine learning in TDS modeling for real-time applications. Future scope: smart water quality systems. Machine learning model can be integrated into IoT-based real-time monitoring systems for automatic TDS detections and improving responsiveness to water quality issues. Predictive maintenance. Machine learning can predict TDS level trends and possible contaminations in advance, helping to take the predictive measures rather than the reactive ones. Scalability for urban planning. Real-time TDS data provides by machine learning can aid to planner and water supply department. Adaptive learning. With continual data inputs, machine learning models can evolve to handle the changing environmental patterns or detect the new contaminations and maintaining the systems more remote and over time. Integration with smart cities. Future smart cities frameworks can use the machine learning driven TDS monitoring for centralized water quality and the controls across the residential and the industrial sectors. Advantages. Real-time analysis. Machine learning enables the fast and efficient analysis of sensor data and making the real-time decision possible. High accuracy. Machine learning models can provide the high accuracy in predicting TDS levels by learning from historicals and real-time datasets. Cost effective. Automated monitoring reduces the manual testing, thus the cutting operational cost in the long run. Automations and alerts. Machine learning systems can trigger alerts or actions when the values or the filters when abnormal TDS levels are detected. Data-driven insights. Machine learning enables the generating of insights and patterns from data and may be difficult of humans to detect.